So now we are going to start the class. Anjali Bisa, good evening, beta. Let's start the class. Present. Okay. Now listen, beta. So if somebody will be asking you about Newton's law of motion, we have done first law of motion, second law of motion. Now we are going to go towards the third law of motion. In third law of motion, usually people say that what is the meaning of third law? What is exactly third law of motion is every action is having equal and opposite reaction. Every action is having equal and opposite reaction. So let's learn it technically and try to understand it in a much easier way and a better way. So now let's see about our third law of motion. Bhavya, good evening, beta. Good evening. After so long, I am starting the classes, children. Uh, okay. Now I'm okay, beta. Now I'm absolutely all right. Now we will be understanding first some examples of Newton's third law of motion. Yes, beta. So now some of our everyday observations. So first we have understood that Newton's I was not well, beta. I went for some treatment. Now my treatment is over. I am all right now. I came safely. Now look here, beta. So now we are going to understand about our everyday observation about action and reaction. Can you tell me where and all action and reactions are there? Then you will be saying that everyday action and reaction is there. If I am taking brush and trying to brush my teeth, means action and reaction both is there. Until and unless I will not be applying force, my brush will not move and tooth will not be getting cleaned. Correct, na? Hmm? That is one action and reaction. Yes. So now this is one action and reaction. Means I have to take my brush, I have to apply force, and then only action and reaction will work. But how we are applying action and reaction at the time of walking? So when we walk on the ground, our foot pushes the ground backward, and in return, the ground pushes our foot forward. That's the action and reaction. So where is action and where is reaction? Our foot is pressing the ground backward, and in return ground is pushing the foot forward. So our foot pushes the ground backward and ground is pushing the foot forward. So that's the action and reaction. So your action is when you are pushing the foot back, when you are pushing through your foot ground backward, that's exactly action, and the ground is showing reaction. The reaction is movement in forward direction. Understood? So exactly it's the help of the ground where you will be able to walk. So action and reaction. Action is when you are walking, you are exactly pushing the ground. Understood? You are pushing the ground backward and the ground is pushing you forward. So this is action and reaction. So walking becomes difficult if the ground is slippery. Why walking becomes difficult if the ground is slippery? Then you will be saying a simple word, because of foot is applying action, yes, and the ground is applying reaction. Foot is applying action and the ground is applying reaction. This is one of the most important thing. Now come on, go for the next one. The another important topic, another important point to be noted. Ma'am, please kindly inform the students class started, ma'am. Now look here, the next important thing is that when we are talking about forward and backward reaction, one thing we have discussed, I just want to discuss that part one more time. So action and reaction will be there, but one more word is there, that is called as friction. So what is the importance of friction while walking? Is friction helpful or is friction problematic at the time when you are walking? How friction helps in walking? See, friction is exactly pushing. The friction will exactly make one, it will allow the person to have a grip. The friction will allow the person to have a grip. This grip will exactly be very, very helpful for a person to walk. So what is exactly their walking becomes difficult in the if the ground is slippery or icy, because the friction of the slippery ground is much less. Understood? So friction provides a grip, and because of this grip you are not falling. Okay, so we exert a smaller backward action on the ground, the forward reaction on the ground will reduce accordingly. Yes, you cannot run on a slippery what you call surface. Why we cannot run on a slippery surface? Because once you will try to run also, you will not be able to run on a slippery surface. The answer is friction will not be. Yes, friction will be helpful for walking, and friction will be opposing motion. Understood? So it will provide a specific grip. Understood? So on a slippery surface, the grip will not be there. So since the grip will not be there on a slippery surface, the friction will be exactly helpful for grip. Okay? Yes, please student, give your attendance please. Bhavya is present. Now look here, recoiling of gun. So first is at the time of walking. Always there was a question at the time of walking, how, yes, at the time of walking, how friction is helpful. This answer we got because we are exactly pushing the ground backward and the ground is pushing us forward. So action is backward, reaction is forward. Understood? So this is how the walking is done. This is how what is done? Walking is done. So now we are going to go for recoiling of gun. So let's check this one out about recoiling of gun. So when we talk about recoiling of gun, Ayushi, good morning, beta. Present. Good evening, Ayushi. Now look here, beta. Now, when a bullet is fired from a gun, what we are doing? We are firing a bullet from gun. What is happening? A force is exerted on the bullet, and the bullet accelerate forward action. So bullet is accelerating which direction? Forward. And where is the reaction? Please say. Yes, the gun is exactly going backward, and that the movement of the gun backward side is exactly considered as what? Reaction. Understood? So equal, but Newton says that equal and opposite reactions are there. So equal and opposite reactions, see, for every action there is an equal and opposite reaction. Our action was the gun going forward. Where is the reaction shows, beta? The reaction is recoiling, that the what you call the gun will go. Yes, the bullet is going forward, the gun is going backward. That is action and reaction. That is action and reaction. So the gun recoils, moves backward through a small distance due to its high mass, giving a jerk to the gunman's shoulder. So in the shoulder, the gunman is experiencing a jerk. So you might be seeing that the gunman is exactly doing like this. This is not for style. This is exactly action and reaction. That's an autonomous process. Okay, it will come directly. The jerk will be because of the reaction. The jerk will be because of the reaction. I hope everybody understood this one. Have everybody understood this one? Put your video in live format and please kindly see. Give your attendance, everyone. Now we'll go for the next one. Amrish, did you understood it? Where is the action and where is the reaction? So now we will go for rocket. So specifically for rocket also, sometimes they're asking this question. Can you tell me for rocket? So we know that the work of a racket. Very good. So, beta, action and reaction. Where is the action and where the working of a rocket is based on Newton's third law. What is Newton's third law of motion? So, where is action? Where is reaction? So, now let's see. A rocket has a combustion chamber with a hole at its bottom. So, this is exactly what? This is the combustion chamber, and holes are there at the bottom region. So when the fuels are burned, it produces hot, highly compressed gases that escapes forcefully from the bottom through a nozzle in the downward direction. Understood? So when the fuel will be burning, it will exactly produces what? Highly compressed gases. Understood? And these gases need a place to come out, and they are exactly coming out from the bottom portion with a very high force, and this will exact action. And where will be the reaction? The reaction will be, the gases will be putting pressure on the ground, and the rocket will be going up. That's the action and the reaction. So the burst gases rushes out from the rear end, that is backward part, and here the reaction will be, it is moving forward. Gases down, reaction is upward. So force on rocket is going upward, this is reaction, and force of gas is action down. So this is action and there is reaction. Action and reaction. I hope everybody understood which one is action and which one is reaction. Understood or not? So now we will go for the next part. Hose pipes. So I think many of you knows about hose pipe. Can you tell me what is hose pipe? Anyone? What is hose pipe, beta? Yes, for watering, but this is not that simple hose pipe. Okay, there is, the firemen are using this hose pipe, and you know what, Bhavya? Can you tell me what is the specific? Hmm. How it is done? Because when you open the hose, suddenly there will be feeling a general, the water will be rushing. To put out fire, see, we need to put out fire. So first, though, you don't think that the firemen will be putting water everywhere. Okay, electrical burning means they are not putting fire water. Okay, so the different ways. Hi Prakash. So the different ways. So first we are going to learn it in a simple way. Okay. So the hose pipe work is to put out fire. Okay. So जो fire brigade होता है उसके pipe. Yes, yes, absolutely correct, Anjali. Yes, but beta, this water has to go with a strong force. This water has to go with a strong force. So now let's check this one out. To put out fire, firemen direct a strong beam of stream of water at fire from a hose pipe. At the water rushes forward. So forward rushing of water. So what is exactly there is forward rushing of water. So water will be moving which direction? Forward. So what is the reaction here? The hose pipe tends to move backward due to equal reaction force. Action is water going forward. Reaction is hose pipe will try to push you forward. You might be seeing that when fireman is exactly taking out water from that the hose pipe they are using, you might be seeing that they are exactly one or two people holding it together and trying to direct into the specific direction where they are wanting to put off fire. So which direction they want to put off fire, that direction specifically they are exactly putting the pipe so that the water is exactly going to, what you call, release that water to the fireplace. So man and boat, how many of you have experienced this one? Come on, check. There is again one live example there. When a man jumps out of a boat towards the bank, the boat moves backward. This happens because when, see, action and reaction, I don't know how many of you have experienced this one, but this is one more example where action and reaction forces are there. So when you will be exactly trying to come out of boat, you might be seeing that just like walking only, forward and backward motion, forward and backward. So when boat will be exactly going which direction? Backward, and you will be going forward. So you might be seeing that the gaps will be there. You know what, if you will not be jumping or you'll try to just go in simple way, definitely you will go between water and the ground. You will be definitely inside. Understood or not? So you have to maintain that motion. So what is exactly that? This happened because when we pushes backward on the boat, action force will be there. The boat exert a force forward reaction. Understood or not? And that's because of that only the person will be able to go front. Otherwise, the person will be exactly jumping between that, or it will be going inside between the water. That's one of the most important thing. Okay. Come on, we will go for swimming. So how people are swimming? Is there any action and reaction force in swimming also? The swimmers, those who are exactly swimming, are they using any action and reaction force? Amrish, can you explain this one out? Okay, Anjali, describe or Bhavya, describe this one. Come on, say this one answer. Come on, say this answer, please. Where is action and where is reaction? Hmm. Swimmer is pushing the water backward and your body will be going forward. Is this action and reaction, please? So he pushes the water backward with his hand and feet. This is action. Where is the reaction? According to the Newton's third law of motion, water will be pushing the swimmer forward. According to Newton's third law of motion, where is the swimmer going? The swimmer will be going forward. So water, see, you are pushing the water backward, water is pushing you forward. So when you are pushing, when you are exactly beating the water and trying to do like this, it is backward movement of water, and water will be, that is action, and water will be pushing you forward. That is exactly considered as reaction. Okay, so this is the game of action and reaction. Now, law of conservation of linear momentum. Our next topic is law of conservation of linear momentum. That means linear momentum or energy or mass is neither be destroyed. Okay, it is what? Say, you were saying so. I just said one word. Now, Ayush. Good morning, Ayush. Good afternoon. Good evening, Ayush. Now, it took 3 times your name. Now, come on, say. You said conservation is mass conserved. So I said energy conserved. Then I said mass conserved. Now you have to explain about law of conservation of mass or law of conservation of energy. Energy can neither be created nor be destroyed. It can only change its state from one form to another. That's called as conservation of energy. But what about conservation of mass or momentum? M1 V1 Neil Hegre N1 V1 is equal to M2 V2. Yes, absolutely correct, beta. But can you be able to explain me how this energy transfer is going on or force transfer is going on? That's the most important thing. This is the final output what you are telling. But let's see. Let's when force will be at that case. What can you tell me? What will be the force at that point? According to Newton's second law of motion, everybody knows that rate of change of momentum will be equal to directly proportional to force. That's according to Newton's what? Second law of motion. I am explaining according to Newton's second law of motion. I repeat, according to what? Newton's second law of motion, rate of change of momentum is directly proportional to force. Okay, so that's the definition here. Okay, that's not a big deal, but now we are going to understand momentum, and momentum I'll not be teaching in this class. So momentum, yes, second law of motion, that's important. But here, hola ma'am, beta, you are in which class? Music 13. Now look here, beta. So Newton's second law of motion, one by one we'll try to understand here, not in hurry burry, but in explained detailed conversation we are going to have. So now look here, beta. We know that moving bodies possess momentum. That's the truth only. Now, whenever any body will be in motion, it will be possessing what, beta? Momentum. What it will be possessing? Momentum. That's a simple thing now. So any body will be exactly moving, it will have momentum. Momentum is what? Mass into velocity. A body having mass into velocity is supposed to have momentum. That's unique thing. No, it's not unique. Okay, 10th. Okay, beta. Anvi, good evening, beta. Now, beta, we'll go for the next part. So, mass into velocity is momentum. Known, already we studied mass into velocity is momentum, not a big deal. Now, if momentum of a body changes from P1 to P2 in time t, then what is exactly force will be? P2 minus P1 is equal to, that P2 minus P1, but that is rate of change of momentum according to the application of force. But if no force will be there, yes, Anvi, if no force will be there, can I ask you one question here? Very slowly I'm teaching today, not at all in hurry burry I'm explaining. I'm simply just talking to you in the class today, correct now? So if someone will be asking you this point, come on, talk to me about it. Okay, if I will not apply any force at that time, and we, I think पिछले बार भी ज्वाइन की थी ना क्लास बेटा, लास्ट टाइम मैथ्स, हाँ ज्वाइन की थी ना, किस क्लास में हो बेटा? कम ऑन से सी, आई आस्क्ड लाइंस एंड एंगल्स, हाँ हेलो वीर, I asked a simple question from you. Now I'm again asking you. If there will be no force, means rate of change of momentum is directly proportional to force. Okay. If I will not apply any force, then what will happen? Because force is equal to P2 minus P1 by T. Time application is there. I mean, sorry, time will be there. Time is one of the important factor we cannot. Yes. Yes, already there, beta. Kushma, Kusuma, yes. So now look here, beta. So now that's Sam or anyone. So now look here, beta. So momentum will change. So body will possess momentum every time. It will be, Saurya, good evening, beta. So now here, definitely it will be changing. So where no force miss, if force will be zero, at that time what will happen? That time, hello Saurya. So that time P2 minus P1 will become equal to zero because force is zero. So momentum in first instant will become equal to momentum in second. So constant, that will be. Yes, so P2 minus P1 you said, time is also there. So time is not there. Wow. So how it is momentum is changing from P2 to P1? See, after 5 minutes or 10 minutes or 11 minutes or 2 seconds, definitely momentum will change from P1 to P2. And that means what? P2 minus P1 by, I went hospital, beta. Yes, Anjali. Momentum 1 will be equal to momentum 2. Simply, beta, I just kidding you. I was just playing with you all. Just understand one thing, beta. So, rate of change of momentum. Where rate is there means time is there. Okay. So, like 5 minutes before, the momentum was different. After 5 minutes, momentum will be different. There will be many factors related to it. Okay. Velocity change will change the momentum because mass is conserved. Mass will not be changed. So, if velocity you are changing, Aryan, hello beta. So here once, Unnati, good evening beta. So once you are changing the velocity, momentum will ultimately change, understood? So rate of change, but this velocity change will be done with time only, na? In a gap of 2 seconds, in a gap of 5 minutes, you will be keep on changing that, understood not? And because of that, force is exactly coming. Force application will be there. Now force will be shown, okay, this part is there, and because of that change, it is force is exactly there. But beta, what if force means what? At the time of changing the momentum, you need to have some external force application on the body, then only change in momentum is there, na? That's directly according to the Newton's second law of motion. So Newton's second law of motion, what it is telling? I am from Chennai, beta. So Newton's second law of motion, directly it is indicating only one thing. Rate of change of momentum is directly proportional to force. So P2 minus P1 in time by time is equal to force. But what if beta no force application will be there? At that time P2 minus P1 is equal to 0. That means momentum there. That means what? Momentum is constant. Momentum is constant. At that time momentum, so when force application will not be there, that time momentum will be constant, understood? So we learned a very important, this means that if no force act on a body, its final momentum is equal to initial momentum. Its final momentum will be equal to initial momentum, and this indicates that the net momentum of the body remains unchanged or conserved. The next net momentum will be what? Conserved. The net momentum is conserved or unchanged. The net momentum is conserved or unchanged. This law holds for a system of bodies. To understand the meaning of the term conservation, let's see some examples. So I hope M is constant. Yes, beta, mass will be constant. Now, mass will not be changing. So now let's see some of the examples. Now, before going for any example, I will ask one question from all of you. Can you tell me, one cycle is there and one scooter, bike is there. Now, bicycle and cycle, they are going with some velocity. And after some time, what happened? They both collided. Will there be any change in momentum for both of them? Will there be any change in momentum for both of them? Anjali, yes, beta, mass will be unchanged. That's correct only, Anjali. I'm asking about beta, when a bike and a cycle, they both will collide. Just pray that no one will get injured. But when a cycle and a bike is colliding, at that particular moment, will there be any shape changes there? What will be, Miss Man will get converted into tomato or something else will happen? Come on, come on. Cycle tire will be punctured. Okay, I can get that. But I just want to know. Just take it for cycle, truck, or anything. Anything. Whichever you are wishing, you try to talk about. You talk about them and try to understand and answer my question. What will happen? Lorry and scooter will fly. Definitely. Then, beta, who gained momentum and who lost momentum? Oh, lorry is getting momentum after collision. That's what. Yes, momentum will change, beta. Hello, Tanisha. Tanisha, after class, one time again you see the video, beta. Okay, understood now, Unnati. But Unnati, there is a very important point here, beta. Just try to understand this part. I just want everybody to answer my this question. One bike, one scooty, they both collided with each other. Momentum change of momentum will be there for both of them. But okay, that means one thing I came to understand by what you called Amrish answer. Amrish is telling cycle will gain momentum and bike will lose momentum. Means one person velocity will be reduced, another person velocity will increase. Though the mass for both the bodies remains the same. So bike person mass will be same as it has before collision, and scooty or cycle person mass will be same as before collision. But at the time of collision, there will definitely some changes. One will gain and one will lose. So let's check who is gaining and who is. Yes, bike person will gain momentum. I think I have to explain this one. Anjali, look here, beta. So now please pay attention for this. So I'll just underline some factors that will help you all to understand this part. Now look here, beta. The velocity of the truck decreases. See, when the truck is colliding with a car, just understand this one. When a truck is colliding, yes, the truck is colliding with a car, means truck velocity will decrease. Decrease in velocity means its momentum will reduce, and car momentum is increased. That's, yeah, because you know what, few minutes back itself Amrish told that the scooty person will be flying. So 100% Amrish told that the scooty person is flying means 100% the momentum of the scooty person is increased. Along with scooty and the person, both will be flying for some time. Understood or not? So that means what? The truck person will be exactly reducing the momentum. Their velocity will be reduced. Once the velocity of the truck which is colliding with the car will be reduced, means its momentum will be decreased. And the car which is exactly colliding with the truck, its velocity is increased because of that collision. Understood? And what will happen? Its momentum will increase. I hope you might have understood how is the change in momentum going. Car will gain momentum. Absolutely. Ha, beta. I will finish chemistry? No. I have to start. No, we need to discuss. We need to start that. Okay. This week, tomorrow itself. I think chapter 2 also we finished. No problem. We'll start. Okay, okay. I'll teach that one also. No problem. Huh? Aha, which score you are going to take the paper? Hi Prashad, I'll repeat it better. So actually I was discussing, just let me finish this topic after that. So tomorrow, because now extra classes I'm going to take for 9. 1 week holiday means extra classes will be coming. Huh? I go to 9 to 11. Sleeping. 9 o'clock. 9 to 12. No, afternoon tomorrow, second half only I'll keep class. Huh? Very good. Night I will keep class for all. I will sleep. No problem, but I'll keep class. Maths class timing tomorrow, I'll schedule and I will give in the online part. 1 to 3. 1, 2, 3. Or 1 o'clock till 3 o'clock. Okay, accordingly I will set the classes. Happy for you? Now happy? Others people are not having problem, only you are having problem. Okay, no problem. Oh, only holidays you will sleep. My name is Khushbu beta. Huh? I'm feeling very sad for you. Shall I? Can I continue my work? After that, I will start chemistry class. Okay. Lines and angles, total portion, Euclid only left. After that, I think I covered total portion. Till lines of angles, so lines and angles only in maths portion will be there. Triangle chapter is there or not, I'll get confirmation. After that. Hmm. Yes, there is app for classes. Shall we go back to our work, please? So momentum will be constant when there is no force. P1 will be equal to P2. And when a truck is colliding with a car, the truck will be losing, the truck momentum will be reduced and the car momentum. That's what beta. See, if mass is more, then final thing is there that mass also is one of the most crucial factor. Understood or not? So if a truck is colliding with a car, see, though both truck and car is moving with same velocity. Now I'm explaining this one. Ameya only beta. So now please understand this. Yes. Which one is having more mass will be creating more impact. That's what I was about to say. So you please remember this one. Okay, Anjali. Now please remember this one. A truck is there having more mass. A car is there having lesser mass than truck. And both are moving with 60 kilometer per hour velocity. Okay. Then what will happen? Who is having more momentum? No, the momentum is not same na, because momentum is directly proportional to mass and velocity. The truck will see both are moving with same velocity, but the one which is having more mass will have more momentum. Understood or not? Are you understanding? Please understand this one, children. Yes. So please understand this part that truck and car both are having same velocity. Both are moving with 60 kilometer per hour speed. Understood or not? But one who is having more mass will have more momentum. Correct? How it will have more momentum? Please kindly check. Momentum is equal to mass into velocity. Now beta listen, here more mass is there and velocity remains the same. So momentum of truck will be more than momentum of car. Understood? So when truck will be colliding with car, car momentum will be increased and truck momentum will be reduced. Understood? So that's what is the concept. Now law of conservation of mass will be saying that system of body remain constant if no net external unbalanced force act on the system. So now beta look here, moving and it is stationary. So this one has given momentum to this one. Understood? Now beta, this momentum, the transfer of energy or transfer of force, whatever will be there, with the help of that the car will come in motion. Understood or not? So the time its momentum will be reduced, this momentum will be increased. So how much momentum will be reduced? Okay, how much momentum will be reduced and how much momentum will be increased? Let's check this one out. Okay, so now look here beta, if they means how much, just understand that simple. I'm explaining that one, that if kg meter per second is there now, so truck lost 20, then car will gain 20. Understood? The loss of momentum by truck is 20, the gain of momentum by car is 20. So is it now counterbalancing? Is it now counterbalancing, beta? Loss of one. Okay, I'll explain that, beta. So loss of one will be giving gain to the other, but equal amount. Understood not? So if 20 is lost by truck, 20 will be gained by car. And this is exactly the law of conservation of momentum. Understood not? That means how much will be lost by one system will be gained by the other system. How much will be lost by one system will be gained by another system. Okay? Understood, Anjali? Now look here, beta. Now we will go for the next one. Proof of law of conservation. So now let's see. So how the momentum is conserved. Did you? Okay, you can drink water. Monkey, go down. Yes. Okay. Now, beta, look here. So, proof of law of conservation of momentum. Suppose two bodies A and B are moving in the same direction along a straight line with different velocities. Now, we are going to talk about different velocities. Before that, मैम लास्ट में आप ऐप का पिक बता दोगे क्या? हाँ बेटा, आई विल एक्सप्लेन. हाँ, नाउ ओनली अरुणिशा इज जॉइनिंग. अरु, वेयर यू बेटा? Now auntie is back, you people are absent, huh? Now one donkey went to drink water. Now beta, look here. So I will be explaining this with these figures only, we will be understanding. Now come here, hey, don't roam here and there, come here. Down, 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 down. Yes. Okay, now let's check this one out, beta. Good evening, beta. Now look here, I'll explain it this one now. Now listen, beta. So two bodies are there. Now first understand that before collision, now both are having velocities. So what is the initial velocity of body A? And what is the initial velocity of body B? The initial velocity of body A is u1. The initial velocity of body B is u2. And their masses are also not same. That means what, beta? What will be the momentum of body A? m1 u1. What will be the momentum of body B? m2 and u2. So momentum of body A is m1 u1 and momentum of body B is m2 u2. So see, what is the momentum? This is before collision. Before collision. Understood? Before collision means just understand that one truck, oh, you went to hospital. Okay, no problem, beta. You can see the recorded part of the previous section. Huh? Now understand this, beta. These two bodies are usually, just like understand that it is a usual day. One truck and one car, they both are moving. What is their initial velocities? U1 and V1. So let's take A as truck and B as car. What is the initial velocity? U1. So U1 is the initial velocity of the truck, and what is U2? Car. Very good. Their masses are same or different? Different. Very good. So now at the time of collision, did you saw one thing here? Which law of what you call Newton is action and reaction? For every action there is equal and opposite reaction. So beta, what is the action? Collision. Understood? So when two bodies collided with each other, so when both the bodies mass is different. Yes, absolutely correct, Anjali. Now look here. When two bodies collided with each other, did you notice something? What happened? When two bodies collided with each other, what they did is the momentum is exactly changed. One lost and another one gained. So that means, but the loss and gain is equal and opposite. That's what I told now. If one is gaining, another one is losing. That means, but the yeah, very good. So car gaining momentum and truck losing momentum. So how much one has lost, same amount another one will gain. And this will be exactly explained by which law? Newton's which law? Third law of motion. For every action, there is equal and opposite reaction. Understood? So here, after collision again, beta, after collision again, the velocity mass remains the same, but velocity changed. Understood? So now here, if you will see nicely here, V1 and V2. V1 and V2 is the velocity of the truck and car after collision. Understood? we will change. So before collision, after collision, everybody understood? Now beta, we are going to understand by change. So change in momentum of body A. Now let's see the change in momentum of body A. Body A was struck na. According to us, what was body A? Truck. So momentum after collision, momentum before collision. So what was momentum after collision? M1 V1. What is momentum before collision? M1 U1 minus, and this is exactly force. The rate of change of momentum by time is nothing but force. So this is the force exerted by the truck. Understood or not? Now, again, momentum of body B. So, can we talk about momentum of body B? Can we talk about car? So, this car is exactly body B. Okay. So, now again, rate of change of momentum will be M1 V1. This is for force F1. We will not talk about it. Rate of change of momentum will be what? M2 V2 minus M1 U1. Now, beta, we'll, yes. M2 V2 minus M2 U2. This is for car. Understood? But beta, we know one very important point, and that point is that Newton third law says that equal and opposite reaction. So force given by, now we will talk about force given by body A to B will be exactly B to A. So one has lost, another one has gained. Understood? So A has given force, external force to B. B has taken that force. Understood? So what happened? Equal and opposite. So F1 is for truck and F2 is for car. Now let's see F1 and F2 relation. I told A to B and B to A. Just check this one out. F1 is equal to minus F2. For every action, there is equal and opposite reaction. So actually, what this is indicating? This is indicating that car has gained and truck has lost. How much car has gained is exactly lost by the truck. How much car has gained is exactly lost by the truck. That's the most important point. So beta M1 V1 minus M1 U1 by T is equal to minus M2 V2 minus M2 U2 by T. First to T and T will get cancelled. This and this will get cancelled. Now this minus will go, what it will become? M1 V1 minus M1 U1 is equal to M2 minus M2 V2 plus M1 U1. Sorry, M2 U2. Now beta U part we will take together, V part we will take together. So what we are getting? M1 V1 plus M2 M1 V1 plus M2 V2 is equal to M1 U1 plus M2 U2. So see M1 V1, M2 U2. So can we check this one M2 U2? So here before and after collision it is exactly energy is totally conserved. Understood? So M2 U2, M1 V1, can we see M1 U1 plus M2 U2? Before collision and after collision the energy is totally conserved. The energy is totally conserved before and after collision. This is exactly law of conservation of momentum. Understood? This is law of, this notes will be available to you. So total momentum, this shows that total momentum of two bodies before and after collision is same. Understood? The total linear momentum of two body remain constant or conserved. It is not affected by mutual action and reaction. Understood or not? So action reaction, at the time of mutual action reaction, they gave and took that momentum. Understood? How much one has lost, that much another one has gained. Understood? But it is actually before and after collision, the momentum is actually conserved. The momentum is actually conserved. That's one of the most important part of it. Now let's see beta application, where and all we are going to apply momentum. Where and all we are going to apply momentum. We are going to check this one out beta. All examples of Newton third law of motion can be expressed in terms of law of conservation of linear momentum, as conserved law of linear momentum has been deduced from Newton's third law of motion. So did we got a very important point? Newton third law of motion was action and reaction. At the time of what you call explaining momentum, conservation of momentum, we use which law of motion? Third law of motion. So when we have used the third law of motion, means the third law of motion can be applicable to whatever examples of Newton's third law of motion we are telling. That time the conservation will be applicable for all those bodies. I hope you might have understood till here. Now come on, go for the next part. So flight of jet plane and rockets. So definitely flight jet plane. So action and reaction, that nozzle part is there na? Huh? So action and reaction. Action and reaction are both and equal and opposite. And there also before and after the conservation will be there. Understood or not? Because the fuel whatever is exactly inside. Amaya coaching only, beta. It's not Amaya Academy. I hope you might have understood. Amaya learning is there. My manager will try to. You just put comment in the our channel part below. Na comment box is there. Na you just comment. My person will be contacting you. Okay. Huh? Very good. So they have a very high velocity and hence a large momentum. So you need to understand that. I am going to explain this one. To conserve momentum of system rocket plus gases, the rocket moves upward with momentum to balance the momentum of the outgoing gases. That's correct only, na? The upward momentum will need to balance the what you call the gases, that is the gases velocity, because the velocity of the gases will only set out the motion of the rocket in forward direction. That's a very important point. Please kindly remember this part. So they have a very high velocity and hence a large momentum. As more and more fuel burns, the mass of rocket goes on decreasing. Sorry, the mass of the rocket goes on decreasing, so the velocity of the rocket goes on increasing. Understood or not? Yes, this is the most important thing here. Mass is not constant. Everybody please pay attention here. Whatever fuel is present in the chamber, fuel chamber, the fuel will be burned. Understood? At a very high rate, at a very fast rate, the fuel will be burned. The burning of the fuel in the fuel chamber will be exactly providing what? Large amount of gases. So these gases will put a pressure on the ground, and this ground will push the rocket upward. Understood? And here this will be exactly, so momentum, upward momentum will be balanced by the gases, which is exactly creating a force in the downward direction. So this is exactly explaining the conservation only. Okay, beta. Before firing, the momentum of the rocket is 0. Understood? After firing, the rocket moves such that momentum of rocket plus momentum of escaping gas is 0. Beta, why? Because forward and backward maintaining each other, and overall force will be considered as 0. So momentum of rocket is equal to momentum of escaping gas, and the momentum of rocket will be equal and opposite to momentum of escaping gas. It will be conserved. Understood? Here negative is exactly showing what? Negative is showing opposite direction. Understood? In the comment box beta, you just say hi, and after that my manager will message you. Okay, Anjali? So similar in the case of jet plane, that same concept of jet plane also working. Recoiling of gun also beta, gun plus bullet. Understood? Gun plus bullet. Again equal and opposite. And when they will be working together, again the net force will be 0. So that is again the case of conservation. So when a gun is ready to fire, both the bullet and the gun are at rest. So initial momentum of the bullet is 0. So when the bullet is fired from the gun, it gives a large velocity to the bullet, and bullet will be going which direction? Forward direction, and hence no external force act on the system, but the momentum of the system, that is gun plus bullet, after firing must be 0, and it will be exactly providing what? Opposing section. I hope. Yes, beta, just send me the schedules and everything about your examination. I will be dealing it. Okay. So recoiling of gun, again, conservation is exactly explained here. So now in next class, we will be doing some numericals, and I will be starting numerical section, and then after that, we will start revision for physics and chemistry. We will start second chapter. Okay. Bye everyone. Wait.